Is your house ready for a heat pump? That's a question I was asking myself about a year ago. So here's my heat pump operating in the winter with a lot of ice underneath it because of all of the defrost cycles during the winter. And there it is again in the spring when all of the ice is almost melted away. And it reveals a 30-inch snow stand. So if you're asking yourself, is my house ready for a heat pump? You should probably ask yourself a couple more questions, like, are my radiators suitable for operating at lower temperatures? How much heat does my house require? Do I need to do any retrofits? Is my house serviced with the appropriate electrical? Do I need backup heat? Well, I'm going to touch on all of these things, plus I'm going to give you a profile of what my house looks like. Okay, so I'm going to tackle 4 and 5. I had a 100 amp service to my house. I needed to upgrade it because the heat pump that I installed had a 50 amp recommended breaker size. So I upgraded it to 200 amp. And I also installed a 100 amp electric boiler for backup heat. So the next question, do I need backup heat? Well, in my situation, I did. The manufacturer spec on the heat pump says it only operates to minus 25 degrees Celsius. I live in a place where it gets all the way down to minus 35 degrees Celsius. So I put in backup heat. So here's a picture of my house. It's 1930s construction. It's 1,750 square feet between the top floor and the main floor. And there is a basement. However, that's not included in the square footage. It's got hot water radiators, previously steam radiators, same radiators, but different method of getting the heat around. It's got R13 in the walls, which is basically just wood chips and wall structure materials. It's got upgraded R60 in the attic. It's got upgraded R30 basement walls. It's got triple pane windows, and it's in Winnipeg, Manitoba, Canada, where we will see anywhere from plus 35 degrees Celsius and slightly hotter in the summer, all the way down to minus 35 degrees Celsius and can be colder during the winter. So that is what I'm designing to. So I want to talk about the cast iron radiators. I have tubular type. And there's a lot of people out there, or experts I should say, who will claim that heat pumps don't work with radiators, or you may have to increase the size of your radiators. Okay. And I found that I did not have to do anything with my radiators when I brought down the temperatures of the supply water, because a heat pump uses less hot water or less. The temperature of output of a heat pump is less than the temperature heat output of a natural gas boiler. Okay, so I have 6 radiators on the main floor and 7 radiators on the top floor. So I think the reason why many people believe that heat pumps don't work with old style radiators, it's because there's a bunch of manuals online, and you might get this graph here that looks like it's been hand drawn, and you might get pictures of column type and tube type radiators that look like the original patent drawings, and you might get a table as well. And when you do the calculations, you'll find that to get any sort of heat out of these, you'll need to operate between possibly 140 degrees Fahrenheit, maybe all the way up to 175 degrees Fahrenheit. And a heat pump typically runs in the 100 degrees Fahrenheit to 130 degrees Fahrenheit. So obviously there is a mismatch here. an incompatibility if you were to go off these calculations. And I just, through my experience, found that not to be true. And I'm going to show you some temperature graphs of my radiators. But one thing that did occur when they were oversizing these radiators, well, I just gave it away there. They oversized the radiators. So it does give us the opportunity to lower the temperature of the water and get decent heat output through them. Okay, so there's an alternative method than calculating the temperature of your water. It's by monitoring your natural gas boiler. Here I've monitored my natural gas boiler, and you can see that at minus 30, it is operating at about 135 degrees Fahrenheit. So already less than those calculations. Okay, so it's almost in the heat pump range. Certainly, if I know that this is below the operating temperature of the heat pump, minus 30, then the temperature of the water of the radiators should be less at higher temperatures outside. But I wanna show you what you can do. You can pick on this middle curve here. So you'll see that there's a call to heat, and then the temperature rises, and that causes the supply temperature to rise as the water goes through the natural gas boiler, and when it comes back, it is cooler, so it's lost the heat to the house. Okay, so but you can see that the cycle for the call for heat cycle is actually quite short. So what you can do is you can limit the upper temperature of your boiler, bring that down, and you'll see probably your supply temperature comes down too. And you'll see that your boiler is actually being limited. It can't get 90,000 BTUs out anymore because it's being limited by the temperature of the supply temperature. Okay, and so you'll see this short little cycle here, which is about 10 minutes. You'll see it move, you'll see it stretch out. So your call for heat will be longer. And once it's on continuously, your boiler, and the temperature continuously, and the temperature of your house is remaining the same at a very cold temperature, you will find that that is the operating temperature for your radiators at that outdoor temperature. Okay, so that's probably an even better method than calculating how hot your radiators need to be. Okay. So I want to take a look at my heat pump at minus 15 degrees Celsius. You can see that the maximum temperature of my heat pump at that point was 115 degrees Fahrenheit. Okay, and at that point, its output is about 50,000 BTUs per hour. Now, my house doesn't require 50,000 BTUs per hour because there's a break in which the house is not calling for heat at minus 15 degree outdoor temperature. But that's what the heat pump is pretty steadily doing. And I know it's pretty steady because the gap between the supply temperature and the return temperature is pretty much the same as you follow the curve when the call for heat is on. Okay, something kind of strange you'll see is this little peak here. That peak is caused by the buffer tank sending that hot water in the buffer tank around the house. It comes back cold because the heat pump is not on. There's just a pump calling for that water in the heat pump, and then the heat pump is triggered to turn on because it's that buffer tank temperature has dropped below its set point, and so it turns on, and then it dips below here because the heat pump went through a defrost cycle. Okay, and so it steals a little bit of heat from the house to melt that ice off of the outdoor unit. Okay, so that's what's going on there. Another little interesting thing here is the house took it appears that no heat was going into the radiators, and that's true because the heat pump went into heating the domestic hot water portion of the buffer tank for that period of time, and then it started back up. But because I'm running and because I'm keeping my house at a constant temperature, I'm just going to write that down because it's important. During that break, I didn't see like much of a drop in the air temperature of my house. It was basically unnoticed, and that's because with a heat pump, you are operating within 1 degree Celsius of your set point, or about 2 degrees Fahrenheit of your set point. You can't really do setback temperatures with a heat pump. Okay, here's my boiler at -30. Its maximum temperature is 126 degrees Fahrenheit. So, and this is this output right here is about 18 kilowatts. And that's 62,000 BTUs per hour. So that is my experience with my radiators getting that much heat out of them at that low of temperature. Okay. So now I'm going to tackle how much heat does your house need at outdoor temperatures. So it actually increases as it gets colder outside. You're trying to maintain the heat of your house. It's getting colder outside, so there's a bigger delta T between the indoor temperature and the outdoor temperature, and so the heat wants to leave your house at a higher rate, and so you need more heat at colder temperatures. Okay, so this graph is showing the heat load here. So this is in BTUs per hour, and this is in kilowatts, just to show a conversion. And at the bottom, I got a temperature in degrees Fahrenheit and degrees Celsius. Okay, and so something kind of interesting here is that the heat pump output actually decreases as it gets colder outside. And that's because the refrigerant is not able to pick up as much heat as the air gets colder outside and bring it into your house. Okay, so I sized my unit. It's about 19 kilowatts. I think it's got a sticker size of 18 kilowatts, but it operates anywhere from 19 kilowatts to about 7 kilowatts here. But my house doesn't need 19 kilowatts at 68 degrees Fahrenheit. It needs nothing, and then it needs a little bit more. I recorded a temperature, I recorded the heat load requirement, and at each point, and you can see that each point lines up with that trend line quite nicely. So that is how much heat is required at each point. Now, what I found with my heat pump is that it stopped working at -20, even though the manufacturers say that it can run to -25 degrees Celsius, which is, to be expected that, you're not getting exactly what the manufacturers say. They're always trying to push the limit of what is actually possible to get a better appearance of their product. But still, pretty good. It wasn't too long ago you couldn't really use heat pumps at low temperatures like this. So beyond that, I'll use an electric boiler. And on this side of the line, I will use a heat pump. And so I've automated this using a controller to turn the heat pump off and turn the electric boiler on. So I'm not actually physically turning things off. That's just too complicated and unrealistic of anybody waking up in the middle of the night to turn their heat pump off, turn their electric boiler on. Nobody's going to do that. So do you have to do any retrofits to your house? Well, it's not a bad idea. It's a pretty good idea, actually, because you'll be able to use your heat pump for longer. So let's say your house was actually using 60,000 BTUs at minus 20 degrees Fahrenheit, just like this green line shows. Let's say that's the condition. Then you can see that the green line passes the heat pump output line at a much higher outdoor temperature. And so, past this point, you're going to have to use backup heat, and that will be likely going to be less efficient, we'll say, than a heat pump. So that's one thing to be cautious about, and you can bring that down by, retrofitting your house and future-proofing your house to use less energy, because it's quite possible that energy will become more expensive in the future. So doing retrofits, using more insulation in your house, upgrading your windows is always a good thing, because you're using less heat than you would if you had an old, leaky and uninsulated house. And you may need to do retrofits to bring down your operating temperatures of your radiators at low temperatures where you want to use your heat pump. Okay, so I hope you enjoyed this video. If you have any comments, leave them in the comments section. If you like my content, hit that like and subscribe button. All right, see you in the next video.